Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to work with one of the useful products about flood hazard mapping. This is JRC Global River Flood Hazard Maps that help you actually to estimate the depths of flooded area, and also you can also anticipate the flooded area with different return period. This product is now available in the Google Earth Engine data catalog and allows you to get information about actually the flood networks and also flooded area with different return period from 1 to 10 or even 500 years regarding to the return period. If you go to the bands here, you can see this data set available with 1000 meter or 1 kilometer that shows the location, spatial distribution, and also the depths of flooded area based on unit measurements that could be very beneficial for flood studies and also understand about the depths of the water bodies in the flooded region. So in the first step, I'm going to show you how to use this product for your region of interest. First of all, this product is available for all around the world and you can use it for your own region of interest. So the first step to actually work with this product, just copy and paste the dataset name into the search places and dataset tabs here. Then you can find it immediately and import it into your code. So now make a new variable. For example, this is JRC, this product produced by the JRC, and also the variable name could be JRC or any other things. So assign the image collection to the JRC and try to visualize the result using the map.add layer. Bring the JRC with actually empty visualization or with normal visualization, or even you can actually help the sample code available here. There is a depth visualization, values and colors, and here you can just copy and paste it for your region of interest into your code. So just like that, and run a code. No need to the map.add layer, and skip the map.center object visualization, and then use the map.add layer. You can visualize the JRC for the global scale, and also here we will have depth visualization already actually brought here through the sample code available there, and the layer name could be, for example, JR flood depths, and use the true at the end to show the data set for whole around the world. As you can see, that shows actually the flooded area over the river networks for all around the world. It's uploading, and also visualization is in progress. And as you can see, for everywhere in the world, you can have access to actually desired information about the flood situation. The benefit of this data is that provides valuable information about the flooded area over the river networks and lakes that could be very beneficial even for lake or river depth estimation. So for example, if you click on a river, no matter which river or which lake you are working, as it is globally, you can use it for your own region of interest. Just go to in the right panel here, there is inspector, switch the inspector, and now click on one of the water bodies or one of the rivers here. Now as you can see, the river depths estimated with a single value that is representing actually in the map, but here in the series, as you can see, we have different depths information based on different return period. So now I'm gonna get more into this topic in this tutorial, and I'm gonna show you how you can actually get depth value for different return periods regarding to your own region of interest. For example, I'm gonna actually select a river and also some lakes in the south of Iran. Here we have Mahorlu and Bakhtagan Lake here, but you can select your own region of interest, and then through the drawing tools available here, you can pick or select your desired area using drawing tools available here. And now I'm gonna actually from JRC format first filter the dataset based on region of interest that is already drawn by geometry. So let's get a print first and see how many actually information, bands and properties do we have for this region of interest. So we have one image collection for this region. As you can see, for the selected region, couple of images available. As you can see, some of them actually highlighted with RP100. RP stand with a return period. If you go to the data description here, you can get enough information about the actually such names we have here. So RP stands for return period, 100 years return period, 10 years return period, 200 years return period, and also the anticipated depths for different return periods actually available here. So for example, if you actually open it up here, you can see in the properties there are different information that you can actually filter your data based on different properties. The main property it is essential here is the return period. For example, if you want to make a integrated data set for your region of interest, first you must select all images with the same return period. So now through the dot aggregate array, as you can see, I can also show a list of return period values. So here we have a list including the return period values available here. Then you must actually filter your data based on different return periods, because the depth value actually changes from one return period to another return period. It's not a very big change, but it is necessary to be considered for the processing steps. So this is the JRC product, and now I'm gonna actually call flood data with a 10 years return period. So bring JRC data first, filter it based on region of interest, and even you can get rid of the next part of the code. Just have focus on actually mosaicing and integrating process. Filter bound based on geometry, and another filter should be related to return period. So here we need the equal filter, earth engine dot filter dot eq. One of the properties comes here. This is a return period. I need those images in which return period equals to 10 or 10 years. Let's get another print from flood 10. Only two images available here for different areas. Actually, as you can see, the ID 166 and 167 or N39 and N29 actually stands for actually frame IDs or something like that. So to integrate them into a single layer, just use dot mosaic them or integrate them into a single layer for the selected area through the mosaic. Let's run the code, and here you have only one image with one band related to the depths. the depths for flooded area anticipated in actually a 10 years return period, and the depths of water bodies available here that could be very also beneficial and useful information for the flood and water body studies. So print flood 10, and let's do the visualization through the map.add layer. For flood 10, it is already converted to a single image through the mosaic. Just clip it based on the region of interest geometry. So regarding to the visualization, you can add a palette you want to use actually beyond the existing palette, or actually in addition to the existing palette suggested in the code example, you can make your own desired palette for the region of interest. So for example, I'm making a palette including these colors. For example, sky blue or light blue and blue and dark blue, for example. These two colors, just like that. The next is the layer name, could be for example flood with 10 years return period, and use the false at the end to avoid automatic visualization. Remember to save your code and run it again. After a few moments, you will have a new image here. Flood 10 image created, and now you can increase the contrast by 90% of values available in this region. But seems something is wrong because we already made a palette. Here I had a typo, sorry for the problem. Now the colored palette also applied. So increase the contrast by 90% of values, or the other better methods. So as you can see here, we can change the contrast by different values. So lighter areas, light blue region, shallow areas, and also very deep blue regions, or actually very dark blue regions shows deeper areas. So if you go to the, for example, if you switch to the inspector status here, when you click on a pixel, you can see the flood value, the flood depth value for the selected pixel. And as this data set provided for the lakes and rivers, that could be also usable for river depths and also the lake depths estimation. When I click on different pixel, and easily I can see the depth value based on meter. If you go to the bands, here mentioned that the depths of the floods actually estimated here, and you can have access easily. But remember that you must filter your data based on the return period, because the depth value changing from one return period to another return period. Typically, in higher return period returns actually deeper values for the depths. So let's try this code for flood with, for example, 20 and 100 years return period. So another variable, flood with 20 years return period, called JRC data, filter it based on the region of interest as a geometry, just like that. And another equal filter, Earth engine.filter.equal. This time return period must be equal to 20, previously 10 and now 20. Make a mosaic layer or integrate them into mosaic image, and then print flood image for 20 years return period. Now a new image available included the depth information for the flooded area with 20 years return period. So let's do the visualization through the map.add layer. This time flood 20 clipped based on geometry. Make a new palette color. You can choose any other palette color you desire, no matter what kind of color palette you are using. So sky blue. I prefer to do the visualization or layout or graphical actually adjustment, all of them on desktop softwares such as ArcGIS Pro or QGIS, because more tools and facilities available there, and we can handle visualization much better than here. But the Earth engine for actually time series data analysis dealing with satellite data is awesome. But for the visualization, it's not powerful actually uh, same as for example ArcGIS Desktop or ArcGIS Pro or QGIS. We have much better tools for the visualization there. Another one is dark blue, the layer name flood 20, and use the false at the end, just like that. So flood 20 is also available. Increase the contrast by 1 sigma. Here you can differentiate depths and also deeper and shallow areas. So switch to the inspector to compare the pixel values in flood 10 and flood 20. As you can see in flood image with 10-year return period, actually the depths estimated around 4.1, but for 20 years period increased to 4.6. That shows the depth value changes for different return periods. So now, for example, you can try this code even for 100 or even 500 return periods. So regarding to your application, you can choose one of these products, one of these return periods by using the filters I'm showing you here, and then I will show you how to get export and bring it up into desktop software. JRC, this time return period equals to 100, flood 100 with the same color palette, color palette, and flood 200, just like that. Save your code and run it again. So here, flooded area with 100 years return period highlighted here. Back to inspector, click on a pixel and compare the values. As you can see, higher return periods returned higher depth values, so for the region of interest. So now I'm gonna show you how to get export from different return periods. Actually, now you learned how to call your product, how to filter your product based on return period, how to do mosaicing or integrate images into a single value, and then I'm gonna show you how to get export using export.image to drive. So export.image to drive is the most popular method to get export from Google Earth Engine platform. Couple of arguments necessarily added here. One of them is image. For example, I'm gonna get output from image with 10 years return period already clipped based on the region of interest. The description shows the name of the output. For example, this is plot 10 for Iran. So my region of interest. The region already defined by the geometry, pixel value equals to the resolution. As the resolution is 1000 meter, scale should be 1000 meter or 1 kilometer. So CRS stands with coordinate system. EPSG 4326. This is a unique universal code you can use for WGS 84 whenever you want to define WGS 84 as a coordinate system for the output wherever. So you must use EPSG 4326, this code actually in the CRS or coordinate system in the Earth as a coordinate system in the Earth Engine platform. So the next is the target folder you're gonna save your data in. You can make any other folders. I prefer to set the test name for the output folder. So, and the maximum pixels you can have for each exporting image must be equals to 1E13. Typically, the max pixel useful for high resolution satellite data, not necessarily used for the coarse spatial resolution, such as 1000 meter. But anyway, you can use it for in your study area. So remember to save your code and run it again. Switch to the task after a few moments. Flood with 10 years return period for Iran is available. Click on run. After a few moments, saving process starts. Once the tab's color turn to the blue, meaning that the saving process successfully done, and then you can pick it up from Google Drive. So until the saving process is done, I'm gonna show you how to use the histogram to get estimation about flood value ranges for your own region of interest. The output is also ready. Let's check the output in the QGIS software, and then we will back to the Earth Engine soon. So click on Open in Drive, and here you will direct it to a new page. Flood 10 for Iran is available. Just click on download, and after a few moments the saving it's actually exported into desktop. And now I'm gonna open the QGIS software here. This is actually the best open source GIS software with UI interface. Everybody knows about the QGIS. That could be very beneficial for geospatial data analysis. So in the QGIS, just go to the open data source first and check the vector, and then click on browse and go to the address. For example, in this address the flood data is available. Oh sorry, it's not a vector, it's a raster layer. Just copy and paste it into a raster tab just like that, and add it into your software. So as you can see, the flooded area with 10 years return period actually available here. The values showing the depths of the flooded region over the river networks and lakes. So, and if you want to increase the contrast or doing some visualization properties, just go to the properties under symbology menu, go for single band pseudo color. For example, there are different, for example, color palettes available here. You can choose one of them, and here you can increase the contrast by different methods. click on apply and OK then. So as you can see, the red areas shows shallow region, and also the blue area actually shows the deeper regions. So 5.4 shows, for example, these pixel with blue colors ha actually has a depth around 5 meter, but this lake here, the depth of this lake is around 2 meter, 1 meter, or less than 2 meter, just like that. There are a lot of symbology tools available here, allows you to do different visualization for your own region of interest. Back to the code here, and now I'm gonna show you how to how to make a histogram for visualizing the depth variation over your region of interest. So let's try with user interface chart image.histogram. As it is already pointed out in my YouTube channel, on my YouTube channel and different tutorials, the histogram is a powerful tool showing you the value distribution and their frequency for the region of interest. So now here, flood with a 10 years return period over the geometry code, and pixel size is around 1000 meter. Let's run a code. In the right panel, the histogram created. So as you can see, we have two borders. The vertical borders shows the depth value, the vertical borders shows the frequency of different depth values, and horizontal borders shows the depth variation from 0 to around 5 meter. Maybe there is some actually outlier values for this area. You can ignore it, but here most of the values actually located between values greater than 0 and less than 5 meter. That makes sense for this region of interest. Among all of the depth product available on the net, this one was one of the actually realistic, or one of the products that is really close to what it is in the real situation. For example, we know that the depth in this area is not much more than 4 or 5 meters, and clearly the same things are reflecting in this product, and I think this data set has a good accuracy, but it still needs more investigation to make sure about the accuracy. But just I'm gonna actually I was going to share this product with you to use it for more investigations, and also try to use it for your own study areas. And remember that whenever you want to use this ready to use product, just cite to the products through the DOI and citations available here, and even you can get more information through the citation and the data reference. I hope you like this tutorial, and feel free to share this tutorial to others and also use it for your own research. Just try to use these products and also try to publish your results about their accuracy and efficiency for your own region of interest. If you had any questions or problem, the code link is available below this video on my YouTube channel, and feel free to reach me out and put your questions and put your comments on my channel. I will try to answer you as soon as possible. Thank you for your attention.